Alright, so on this video we're going to be going over 11 of the problems for the test review, and then 11 of them will be taken for a grade. So this test goes over parent functions, so like your rational functions, your exponential functions, and then it goes over the transformations that occur on each of those. So make sure you're aware of the key attributes as well as the transformations. So number one, it says to determine the x-intercept of the function. So whenever we're finding an x-intercept, that means my y value is going to be 0. So we have 0 equals 2 to the x minus 4. And we want to solve that for x. So we'll add 4. 4 equals 2 to the x. We can make them have the same base, so 2 squared equals 2 to the x, which means x equals 2. So my x-intercept would be 2, 0. Then on number 3, we are determining the horizontal asymptote for 10 to the x plus 8. For our exponential functions, whatever's behind the exponential is going to be what my horizontal asymptote is. So we have a horizontal asymptote where y equals 8. Number 5. For the parent function, f of x equals 10 to the power of x, y equals 1 at the point 0, 1. We want to determine the coordinates of the point where y equals 1 for the function g of x equals 10 to the power of x minus 5. So we're going to plug in a 1 for y. Now we can do this several ways. One is to convert the log base 10 of 1 is equal to x minus 5. Any log of 1 is 0, so 0 equals x minus 5 plus 5. We get 5 equals x. So then the x coordinate where y is 1 is 5, so we would have 5, 1 as that point. Number 6, just a refresher, writing it as a single log, so we're condensing. So we want to take those exponents, make them into, we're going to take those coefficients and make them into exponents. And then since we are subtracting, it's going to be division, since they have the same base, that is 10. So this is x to the 4th over x plus 2 to the 6th. Number 7, we're expanding of log base 3 of 11 p cubed. First, we'll separate that multiplication between the 11 and the p cubed. And then we'll bring down that 3. So log base 3 of 11 plus 3 log p. Number 9. Determine the domain and range for this log function. Remember, our log functions general form look like that, where they're approaching some value and extending on forever in the up and down direction. So if we took a function like that, and we have just this transformation here where we're moving up 6 units, then my range can't change just because it's going to cover every single value. So my range is going to stay all real numbers. And picking up and moving that graph 1 or 6 units, 1 unit, 3 units, it's not going to change the domain. What's going to change the domain is any left or right movement, which we don't have. So my domain is going to stay infinity, nope, 0, sorry, to infinity. Number 10, we want to determine the coordinates of the y-intercept and the vertical asymptote for this log function. So we're going to find the y-intercept, which means that x is 0. Log base 10 of 4, which is, it says round to the nearest thousandth, so 0.602. And then the vertical asymptote, we're talking about a straight up and down line. So that changes with this left-right movement. Our asymptote is going to move to the left 4 units. Now let's move on to the second page. Number 13. What value of y is not included in the range of the function y equals 1 over x minus 5? So it's asking what value of y is not in our range. So we've got some function. General form, they look like this. So we've got some rational function. And we want to know what value of y. So we want to know where our horizontal asymptote is. So we're going to rewrite this with a common denominator. Negative 5x plus 1 over x. And then in order to find the horizontal asymptote, we go Bobo Bottom. Eats DC. I know some of you really don't like that, but it's the easiest way to remember. So with that, we're going to take negative 5x over x, which would be negative 5 over 1, which is negative 5. So the value that is excluded from the range is negative 5. Number 17, we want to find the vertical asymptotes in the holes, if we have any, for this graph. So I see x minus 1 on top and on bottom, which means this is equivalent to x minus 3 over x minus 5. Vertical asymptote we get from where the denominator equals 0. Holes we get from whatever crossed out equal to 0, and then plugging that value back in to our simplified version. So we got 1 minus 3 over 1 minus 5, which is negative 2 over negative 5, which is 2/5. So our vertical asymptotes occur at x equals 5 and x equals 1. So just x equals 5. And the whole occurs at 1 2/5. Number 20, find the horizontal asymptote, which again is Bobo button. HDC. And so we've got this function. We're just going to take the first ones and look at their powers. The powers are the same. So this is HDC, which means we're going to divide the coefficients. So the horizontal asymptote would be y equals -2/2, which is -1. On 22, we want to graph the rational function. So I went ahead and sketched out a little coordinate plane over there on the right. So in order to graph our rational functions, we need to factor, if we can. The bottom, I can already tell, is a special case. It's a difference of squares. So we've got +3 and -3. And on the top, we need two numbers that multiply to +3, but add to -4, which would be -1 and -3. So we cancel out that -3. And an equivalent rational would be x minus 1 over x plus 3. So we need to find the x-intercept, the vertical asymptote, the y-intercept, horizontal asymptote, and then any holes. So the vertical asymptote is wherever the denominator equals 0. So x plus 3 equals 0 means we have a vertical asymptote at x equals -3. Go ahead and sketch that there. Horizontal asymptote. My coefficients are both 1. We've got 1 over 1, which would be y equals 1. For the x-intercept, we would have 0 equals x minus 1. We just look at the numerator. So where x equals 1, we have an x-intercept. And then for the y-intercept, look at a 0 for x. So -1/3. And then the whole, whatever we canceled out, which was x minus 3, we set that equal to 0. X would equal +3. And then we plug that into the simplified version. So 3 minus 1 over 3 plus 3, which is 2 over 6, which is 1/3. So we have a whole at 3 1/3. And then our graph will approach the asymptote, go through its intercepts, and then reflect on the other side. So then those are the ones that I will be going over in this video. As always, if you have questions, feel free to ask, and then we'll get back to you as soon as we can on those questions. Remember to do the remaining 11 for credit on this review. Again, these reviews are being taken for grades this 6 weeks, so make sure that you're getting them completed and that you are turning them in on campus. So if you have any questions, reach out, and if you don't, good luck, and I'll see you in the next one.